Yeah, so absolutely. My name is Thomas Whitaker, and I was a laboratory assistant working with Hans Geiger during this experiment, and Ernest Marston, of course, in what became known as the gold foil experiment. Going into it, I really had kind of no idea what our experiment was setting up for in the course of history, really. Uh, well, at first, of course, we were really just testing the current theory of the model of the atom, which was the plum pudding model, where they kind of like blob together and this and that. So that's what we were testing, you know. But as for the actual experiment, of course, everyone that's even heard of physics has heard of the gold foil experiment, which is what we did. But what we actually did in the experiment was we accelerated particles and we hit sheets of gold. And what we expected was obviously not what we got in the experiment. We expected, um, we wanted them to go like straight through with little to, no deflection, nothing dramatic. But we wanted to measure how those alpha particles scattered when they hit the gold. So we were trying to confirm the existing theory, not completely derail it, which is what we ended up doing. Where did the project occur? So it actually occurred at the University of Manchester in England in a dark, dark basement. So it happened in England and in a basement, which definitely two places no one wants to be. What was going on in the world at the time? What wasn't going on in the world at the time? It was the early 1900s. The Wright brothers had just invented the first aircraft. Tensions were rising. World War One was about to begin. Einstein was starting to make waves with his work. So it was really a lot was going on in the world of science and physics at the time, and we just kind of went straight into it. So, along with myself, I was just a laboratory assistant, of course, but Hans Greger was a senior researcher that I worked under. If his name sounds familiar, it should. He later went on to invent the Geiger counter, which is what we use to measure radiation and things like that. Uh, Marston, who was also on the research team, was younger than Geiger, but just brilliant as well. He was the first one who noticed all the deflections, actually. And overseeing everything was Ernest Rutherford, another should be familiar sounding name. Rutherford didn't work directly with us in the basement when we were shooting the particles, but he's the one that interpreted the results and actually included that what we did would change physics forever. What was my role in the project? Well, as a laboratory assistant, I mainly helped with the kind of menial tasks around with the experiment. So that's, repairing the apparatus, preparing the gold, and I also counted the little tiny flashes of light where the alpha particles hit the screen. It sounds small, but each flash represented a fundamental interaction on the atomic level. We had to record thousands by hand, by eye, often working in shifts to make sure that we got enough data. So it was really kind of, grueling stuff. Our experiment, well, it kind of impacted everything and it changed everything, which is not what we set out to do, but it definitely had a profound impact. Our results showed that a small number of alpha particles were deflected at very large angles. Some even bounced straight back. That should have been impossible given our current understanding of the atomic model, which actually led Rutherford to conclude that the atom must have a very small, dense, positively charged center that allowed it to deflect at angles and directly back. Our experiment ultimately led to the planetary, theory of the atom with, a positively charged nucleus and orbiting electrons. Our experiment opened the gateway to a whole new era of physics and ultimately quantum physics, and it completely changed how we understood science and matter. Did I realize how important it was at the time? No, none of us did. Like I said in the beginning of the interview, we were ultimately trying to confirm the current theory of the atom, not completely change it. At first, we thought we made a mistake. Um, I remember going to Geiger and saying, "Sir, some of the particles are bouncing back. We must have set something up wrong." But then we double checked everything, and when Rutherford heard it, he went quiet for a moment, and then he just said something I'll never forget. It was as if you fired a 15-inch shell at a piece of tissue paper, and it came back and hit you. That's when it hit me. We weren't just confirming a theory, we were discovering something new. We were debunking the theory, and that is a rare, humbling feeling. Of course, thank you for interviewing me, and thank you for taking this time, and I hope you learned something about physics and about the gold foil experiment we did. Thank you.